Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 19, Atoms, Molecules, and Ions, Part 6. This is the last video in Chapter 2. Here are our objectives for today's video. We're going to be talking about covalently bonded nomenclature. Pause here. So type 3 binary compounds, they contain two nonmetals, and they are covalently bonded. Pause here. So some of you have probably heard water sometimes referred to as dihydrogen monoxide. That's something that's useful to remember when naming type 3 compounds. So the first element is named first using the first element name, so hydrogen. The second element is named as if it were an anion, meaning that we're changing the suffix to IDE, hydrogen oxide. Then we're going to use prefixes to note how many are present. I'm going to put the prefixes on the next slide. So dihydrogen monoxide. But if for whatever reason the first element only has one, then you are not going to use the prefix mono. Pause here. These do need to be memorized, though I do think that they make a lot of sense, especially with you taking geometry at the same time as chemistry. Pause here. These should be pretty straightforward. So sometimes students ask me, like, how do I know how to change something to be, like, is it trioxide, is it trioxanide? I'm typically not super strict about that on a test, just so long as you demonstrate that you know how type 3s are named, then that's fine by me. Just so you're aware, for a lot of these compounds, especially ones that contain carbon, there's actually other naming systems that you'll find. So if you actually Google some of your answers, sometimes you'll find things that are a little bit different than what we learned in class, and that's something that we could talk about in person, but just be careful with looking up names online, especially some of these have common names that don't even follow nomenclature that are commonly used. Pause here. So we have our type 1, our type 2s, and our type 3s, and acids are kind of their own thing. So they are covalently bonded, so they're more similar to type 3s than they are to type 1s or type 2s. But when they react with water, they actually become ionic, and that's what makes them really special. So all acids are going to start with hydrogen. That's something that will be useful for you to know. So then it will be bonded to something that's forming an anion. So if the anion does not contain oxygen, meaning it's likely to be from the halogens, you're going to, the acid will have the prefix hydro, and then the suffix ic, and then we just put the word acid at the end. For example, hydrochloric acid. And then if it does contain an oxygen atom, meaning that we are talking about a polyatomic ion, the suffix of the anion is changed, and then the word acid is added to the end. So sulfuric acid comes from hydrogen being bonded with sulfate, and then nitrous acid comes from hydrogen being bonded with nitrite. Pause here. Okay, so for the first one, HI, this is the first category, so it doesn't contain any oxygen. So hydroiodic acid. And I've got HNO3, so this is coming from nitrate. So if I have something that ends with 8, this becomes nitric acid. Then I have HCN. So this is cyanide. This also contains no oxygen. So this is hydrocyanic acid. I've got HClO3. I'll actually have to look up what this one is. ClO3 is chlorate. So it's ending with 8, so I change it to ic, chloric acid. HClO4. So ClO4 minus is perchlorate, so this becomes perchloric acid. And then I've got H2SO4, so sulfate, so I change it to ic, sulfuric acid. Thank you so much for watching and have a great night.